The transport control protocol is connection orientated. That means that two hosts or a client and a server, for example, if they want to talk between each other, they will build a connection. We will see how that connection will be built or teared apart close to the end of the video when we will talk about the TCP three-way handshake and the TCP states. The first field, TCP source port number, it identifies the sender's port. The same idea and the same concept as the UDP source port number, it applies here. The same applies for the TCP destination port number. The sequence number has two roles. If the SYN flag is set to 1, it means that this is the initial sequence number. The sequence number of the actual first data byte and the acknowledgement number and the corresponding acknowledgement are then this sequence number plus 1. If the SYN flag is clear, that means it's 0, then this is the accumulated sequence number of the first data byte of the segment for the current session that you have going. The acknowledgement number has the same size as the sequence number, and if the acknowledge flag is set, then the value of this field is the next sequence number that the sender is expecting, and this actually acknowledges the receipt of all the prior bytes. The offset field will tell you what is the size of the TCP header in 32-bit increments, and it gets the name from the fact that is also the offset from the start of the TCP segment to the actual data. The minimum length of the TCP header is 20 bytes and the maximum one is 60 bytes, and it will allow up to 40 bytes of options in the TCP header, of course if this field will be used. In the reserved field we have 3 bits which are always set to 0. In some of the networking books you'll find that this is reserved for future use, so in case you will try to set these 3 bits to 1, they will gonna get dropped by firewalls or routers. Now, one of the most interesting fields in the TCP header is the field where we have the flags, and in this field we have 9 bits. This field can actually be divided into 2. The first 3 bits are used for explicit congestion notification, ECN, and the rest of 6 are called control bits. This bit over here is optional, and it was added to ECN with the intention to protect against accidental or malicious concealment of marked packets from the TCP sender. The second one, it's called CWR, and it stands for congestion window reduced. So if this bit is set to 1 by the sender, it will tell the receiver that the congestion window has been reduced. So when the window is reduced, the sender will send less data in a specific time frame in order to deal with the network which is overloaded. The third bit, ECN echo, and it has 2 roles, and this bit actually depends on the value of the SYN flag. If the SYN flag is set to 1, it means that the TCP peer or the remote is ECN capable. In case the SYN flag is clear, it says that a packet with congestion experienced flag set to ECN of 1.1 in the IP header was received during a transmission, and this tells the sender that there is a network congestion. If you forgot about the ECN field in the IP header, let me give you a quick reminder. So you can find it here in the IP header. It's the 4th field with only 2 bits. Going back to TCP header and finishing the first 3 bits from the flags field, we have the control bits, which are 6 of them. These ones over here. The first control bit is the urgent pointer, and is used to indicate that the packet should be prioritized over other packets. Most of the times this bit is not set. The second one is the acknowledgement, and this one is responsible for acknowledging the packets that were received. You will see the acknowledgement after all the synchronization between the client and the server is done, and it should always be there. The third control bit is called push, and it tells the TCP protocol to push all the buffered data to the receiving application, no matter how much the TCP window was pushed or not. Fourth bit is called reset, and it's used to tear down a connection. The fifth bit is called syn, and it stands for synchronize. This one is used to synchronize sequence numbers and is used only when two endpoints will start a connection. And only the first packet sent from each host should have this flag set. The last control bit is called fin and is used only for the last packet from the sender, which tells that it has no more data to send. And when the other host will receive that, and when the other host will receive the packet, it will reply with another packet in which we will gonna have the fin flag set plus an acknowledgement, and the connection between the two hosts will be closed and put into a TCP closed state. Remembering all the TCP flags for CCNA exam is not mandatory, but at least you should know about the syn, the fin, and the acknowledgement flag. These are essential for the TCP three-way handshake. However, if you still want to find a way to remember all these flags, you can use the mnemonic that I have specified here in the flashcards, which is not commonly explicit, unskilled attackers, pester, real security folks. NOT stands for NS. The second one is CWR, stands for congestion wind reduced. Explicit stands for ECN. U stands for urgent pointer. Attackers for acknowledgement. P for push. R for reset. S for syn. And F for the fin flag. This one I actually found it on the internet, and in case you want to Google it, you can type it here: unskilled attackers, pester, real security folks. And here you can see the first link. You can click it. Here you can find the mnemonic. The window size field, it is used by the receiver to tell the sender how much data it will permit at that specific moment. This is done by sending an acknowledgement back to the sender, which will contain the sequence number that we want to acknowledge. And the window field contains the maximum accepted sequence numbers that the sender can use before he receives the next acknowledgement. The next acknowledgement will update the accepted window which the sender may use. In the TCP checksum field, we will have a value which is generated by the sender as a mathematical technique to help the receiver in order to detect if the messages were corrupted or tampered. This value will cover the TCP header, the payload, and the pseudo header. The urgent pointer field will be used only if the urgent pointer flag will be set into the flags field. And this will be an offset from the sequence number that will be used to mark where the urgent data ends, which requires priority for processing. The TCP options can be used if this field will have a value bigger than 5. This field has also a variable length that can contain optional headers which can be used. The most known TCP options are maximum segment size and the window scale. The maximum segment size is a parameter that specifies the largest amount of data that a computer or endpoint can receive in a single TCP segment. The window size in TCP controls the flow of the data, and its values are limited between 2 and 65,535 bytes. And in case you want a complete list of all the TCP options, you can find it here. I have put an URL into the flashcards over here. So you can go and check it out. In the TCP header, we have another field which is not present in the picture or into this diagram over here. This field is called the padding field, and all the bits in this field are set to 0. This field ensures that the TCP header ends at 32-bit boundary and the data begins to prevent the loss of it. Thanks for watching, and stay tuned for the last part when we will talk about TCP three-way handshake and the TCP states.